I'm going to be presenting this Atlas of Economic Complexity. And as you can see, this is the result of major teamwork. Cesar Hidalgo is my partner in crime. He's a professor at MIT. He started being a fellow at the CID until MIT stole it from us, but now we are stealing their technology from them. So it's turned out quite nicely. Sebastián Bustos, Michele Kosha, Sara Chang, Juan Jimenez, Alexander Simoes, and Mohamed Yildirim are people that we were able to mobilize because we had resources. And we had resources because we were generously supported by Alejandro Santo Domingo, by the Empower Foundation, by Standard Bank, and by a donor that decided to remain anonymous. So these things don't happen on their own. They happen with people and they happen with resources. So I would like to thank you all for the support. So we ask some simple questions out there. The first question is, why are some countries rich and other countries poor? And why some countries catch up and other countries don't catch up? Who is poised to catch up? And what can be done to accelerate the process? And that, in essence, is what economic development is all about. So let me start with this graph. This graph is the income per capita of the US since 1500. And since 1820, incomes per capita in the US have gone up by a factor of 25. So that's a fact of the world. Incomes in the world have gone up enormously. Now, this did not happen everywhere. What I have here in this graph is how many times was the US richer than these other countries. So while the US started in, say, 1820 being about 3 times richer than China, by 1970 it was 20 times richer than China, it was 20 times richer than India, it was like 12 times or 15 times richer than Nigeria. Now, if you look at what happened afterwards, okay, you see, we now are seeing that India and China are starting to catch up. Okay, so the US is now some 5 times richer than China, no longer 20 times richer than China. But if you see, Nigeria is still getting poorer. So the dynamics, some countries are catching up, other countries are not catching up. Not everybody is catching up. So the question becomes then, why did the US become 25 times richer, and then why didn't others just do the same? Okay? Well, there is a standard answer that you probably have heard. Why the US became richer is because you become richer by using more land, more labor, more human capital, and more physical capital, right? So it's about education, finance, and stuff like that. And our take on it is that essentially the fundamental view on this point is that no, that's not how countries grow, okay? So countries grow because they learn how to make things that they did not know how to make before, or they learn how to make things better or easier than they did before. So in 1820, the US was not making any of the products in this picture, okay? It's not that they got to produce more of the same, they changed dramatically what they produce and how they produced it. So the US has learned to make more products and better products. So the society has learned to make more things. Now, who is it that has learned? Who in the society has learned? And then that's a question, what is the difference? Is that now, compared to 1820, people now in the US are geniuses, that they know umpteen times more than they did before, or what? Who is it that learned to make so many more products? And to answer that question, I'm going to compare the knowledge set of an Inuit, okay? So here is the Inuit producing food, and here is the Inuit producing housing, and here is the Inuit producing transportation, okay? Now, this is modern man. Now, who knows more? Well, I would put it to you that this modern man doesn't know how to make a sweater. He doesn't know how to make glasses. He doesn't know how to make paper. He doesn't know how to make a pen. And much less does he know how to make a computer. This man is fundamentally useless. In fact, if you took him to the Arctic, this man dies within the first night. Okay? So it's not that this guy knows much more than the Inuits. They know different things. The fundamental difference is that this guy is one small piece of a much broader machine, while the Inuits know pretty much everything that the Inuit society knows. So let's see how knowledge grows. Let's start, we are at Harvard, so let's start at Harvard. And Harvard started in 1636 in this building, okay? And since 1636, knowledge in the world has expanded. In 1636, a college degree lasted 4 years, okay? And we had a diploma. College degree lasted 4 years. Since that time, knowledge has expanded enormously in the world, and the university expanded with it, and the university expanded with it, and then the university expanded with it some more. Okay? So now we have much more knowledge than we had before, and therefore, today, a college degree does not last 4 years. A college degree lasts 200 years, because we have so much more to teach. Right? Wrong. We don't have college degrees that last 200 years. We still have college degrees that last 4 years. And the way we accommodate so much more knowledge is by distributing this knowledge among different majors. So people specialize in different areas. It's not that you get more knowledge per person, you get chunks of knowledge distributed to more people. And that is the way knowledge in the world increases. And that is because learning to make things is hard. Now, this guy here is Michael Jordan. Okay, he's probably the most talented basketball player ever. And one day, Michael Jordan decided that he got bored from playing basketball, that he was going to become a professional baseball player, sorry. And Sports Illustrated, that thought that he was the greatest man ever alive, asked him to quit, because he never made it as a professional baseball player. And Malcolm Gladwell, who was mentioned last night, would have said, well, he did not have his 10,000 hours in basketball. So the point is that learning things is hard. Because knowledge is hard to acquire, it's hard to embed. Learning a language is hard to acquire, it's hard to embed in yourself, so it takes time. And because of that, it's inefficient to put too much stuff on your head, because by the time you've learned everything, you are too old to work. So essentially, we are all limited to a certain amount of knowledge we can embed in ourselves, and we call that limit one person byte. So we're all limited to at most one person byte, and the question is, how can you have a society that has many person bytes? So the Inuit society had essentially one person byte because everybody in that Inuit society knew how to make everything. We are limited to one person byte, but our society has many, many more person bytes. So products are made with knowledge, but products typically are made with more knowledge than one person byte. Okay? And products are going to differ in the amount of knowledge they require, in the amount of knowledge they embed. And for example, some products have a certain complexity. There's a certain amount of different person bytes, different sets of knowledge, different minimum number of people that have to be involved with different knowledge sets to make them. Other products are more complex, and other products are even more complex. So this is the Dreamliner 787. It's made in all of these countries in the world, in all of these companies, different pieces, different things. It requires a lot of embedded knowledge, a lot of person bytes to make one of these things. So when you look around the world, I'm going to present you this little factoid. In the US, the average worker works with 99 other co-workers. So that's the average, the weighted average of the firm size, okay? So on average, you would say 100 different workers, okay? So maximum 100 different person bytes, maximum, right? In India, the population is 4 times larger. So you would say, well, if in the US it's 100, in India they have to fit 4 times more people. So on average, say a worker works in India with 400 other workers. Well, that's not the case. They work with only 3 other workers. So a typical firm size is size 4. So that tells you something of how many person bytes you can aggregate with a firm size 4 versus a firm size 100. Okay? Now, this makes you ask yourself the question, and people have been pondering these days, why has micro-lending not been more transformative? How many person bytes can you add in a micro-enterprise? okay, vis-a-vis the standard a larger firm. Now, it doesn't mean that more people means more person bytes. Okay, doesn't mean that more people are more person bytes, because what matters is how different these person bytes are. So this is a chicken meat factory in China, okay? And you can imagine that pretty much everybody here is having the same person byte, as opposed to, say, a symphonic orchestra, where everybody is, I'm going to shut this up. Everybody's having a different person byte. So you see, the amount of knowledge that is embedded in products is going to depend on the variety of knowledge that you can distribute between people and then reaggregate in people. So to hold knowledge, you need to distribute it between individuals, because we're all personally limited in how much we can hold. To use knowledge, you need to bring these individuals back together through organizations and firms, or by buying this knowledge embedded in products through your inputs, that is through markets. So organizations and markets are the other side of the coin of this expanding set of productive knowledge in society. So the complexity of a country's economy is the other side of the coin of this accumulating productive knowledge in society. And that's why we care about economic complexity, and that's why we measure it. So how do we go about measuring economic complexity? Well, obviously, if you want to measure it, you have to look at the world. And here is the picture of the world. Now, in this picture of the world, it's hard for me to see anything other than lights. But this is another picture of the world that we find extremely informative. Now, you see here, everything is clear. Now, what this is a picture of the world. It's a different picture of the world. Every line here is a country, and every column here is a product, and every pixel tells you how much of each product each country makes. Okay, so it's a picture of the world. It captures all of the exports of all the countries, of all the products of the world. Okay, it has 500,000 pixels. Okay, now you are going to say, yeah, fine, but I still don't see anything here. Now, if you allow me to reorder this, it takes this shape. I've just reordered countries not alphabetically and products not by code. And it takes this shape, and the funny thing about this shape is that it says that some countries make everything, and other countries make very few things. It says that some products are made by everybody, and other products are made by few countries. But what gives it the triangular shape is the fact that the countries that make few things tend to make things that everybody makes. And the countries that make many things, make those things too, but they make things that few other countries make. And this is a feature of the world that we think expresses this accumulating knowledge in the world. So rich countries don't specialize in different things than poor countries. Rich countries make everything, poor countries make few things. And that's what we observe in the data. Now, this was true for the world. This is true also for Chilean municipalities. You have exactly the same triangular shape. Some municipalities make everything. Other municipalities make few things. The municipalities that make few things make things that everybody makes. And so this is a feature of the world. And we're going to interpret this feature of the world based on this theory of productive knowledge, so that things are made with productive knowledge, with different person bytes. Okay, so some products require more person bytes, other products require fewer person bytes. They differ in their complexity. And countries differ in the person bytes they have, in the variety of knowledge that the brains of their citizens hold. Okay? And so when you put these things together, countries are going to make the products for which they have the requisite knowledge. And that is why we observe which countries make which products. Okay? And we can use this trick to measure how much productive knowledge societies have, because countries that have more person bytes are going to have what it takes to make more products. That is, they'll be more diversified. But products that require more person bytes will be accessible to fewer countries, because unless you have all the person bytes, you can't make the product. So they will be what we call less ubiquitous. Countries that have more person bytes will be able to make products that require more person bytes. So if you have, it's not only you'll be able to make more products, you'll be able to make products that require more person bytes, but products that require more person bytes are accessible to fewer countries. They're less ubiquitous. Products that require more person bytes should be made by countries that have many person bytes, but countries that have many person bytes are likely to be very diversified. So I can tell a lot from what you make, and from the other countries that make what you make, I can tell something about how many person bytes you have. And this is not unlike what they use in college football. In college football, to decide who won the championship, they cannot make everybody play against everybody, so what they do is they count how many games did you win. But not just how many games did you win, how many games were won by the people you beat, and how many games were won by the people who beat the people you beat, right? So that there's information not just in how many things you make, but in how hard it is to make those things, how difficult it was to beat the people you beat, and so on. And that's the formula they use for college football. That's essentially the approach we take today, and that's how we measure economic complexity. And we find this is a picture of the world where the color represents how complex countries are, and at the top we have Japan, Germany, Switzerland, followed by Sweden and Finland, and so on. The US is over there. You see Mexico is fairly complex, much more complex than the rest of Latin America. Brazil is less complex than Mexico, but more complex than Venezuela. There is a lot of complexity here in Europe. You see in Eastern Europe, there's quite a bit of complexity, and there's quite a bit of complexity in China, in Thailand, in Korea, less so in India, and so on. And this is Africa. So when you look at the statistics, we come up this way. Okay, typically, rich countries have this, if you want, is how many person bytes you have. This is how rich you are. You see that there's this positive relationship. It's not perfect, because there are countries like here, Kuwait, which is very rich, but has very few person bytes. Why are they so rich if they have so few person bytes? Well, because they have a lot of oil. And that's true of all these countries here. Azerbaijan, Venezuela, Libya, and so on. They are very rich for the very small level of person bytes that they hold. Okay? That's because something else is making them rich. What's making them rich, obviously, is natural resources. So when we control for natural resources, we get this relationship. The more person bytes you have, the richer you are. And in fact, person bytes, as measured in just counting the things you make and how difficult it is to make them, is a very, very good predictor to how rich you are. And the R-square is 0.73. Now you're going to tell me, yes, Professor Hausmann, but you know, it's nice, but it's not perfect. You know, your theory makes mistakes about the world. You know, some countries are richer than you think they should be, and some countries are poorer than you think that should be, so your theory is wrong. To which I like to say, well, maybe my theory is wrong, or maybe the world is wrong. And I'm willing to believe that the world is wrong, and it will abide by my theory. Why? Because take a country like India. We say India has very many person bytes for how poor they are. They shouldn't be that poor. So we would predict India is going to grow. It's easy for India to grow because they already have the person bytes with which to grow. Now, if you go to Greece, this is a country where we cannot fathom why it is that they are so rich, given the few things they know how to make, right? And how easy it is to make the few things they know how to make. So we are not terribly surprised that Greece is in trouble. That is, Greece was able to sustain that level of income because they borrowed themselves to prosperity. But now the bill is there. So actually, in this gap between how many person bytes you have and how rich you are, we can predict how much you're going to grow in the future. And what we have here on the x-axis is how complex you were in 1998, and what we have in the y-axis is how fast you grew in the subsequent decade. And we can do this for different decades, and so it means that this accumulation of person bytes, it's what ultimately drives growth. Now, you might say, okay, so you're saying it's productive knowledge, so you're telling me that it's about schooling, so we should send people to school, right? And you immediately realize that it's not about schooling, because if I send you to school, to a better school, the morning after, you don't know how to make shoes, you don't know how to make paper, you don't know how to make airplanes, you don't know how to make anything, right? It's not something you learn in school. It's a knowledge that gets embedded in the productive activities that a society has. So we did a horse race in this book, comparing how well does our measure of economic complexity explain growth vis-a-vis other measures. So here we're comparing with education. So the bar expresses how good a job we are at predicting growth over the subsequent decade, okay, for the past 3 decades. And this is how much economic complexity measures. This is education and different components of education. So we do much better than education. So it's not about education. It's not about governance. So everybody says, no, it's all about the rule of law and so on. So we compared with the World Bank governance indicators, with all 6 governance indicators together, separate, and so on. We explained something that they are unable to capture. So if it's, Adam Smith says the secret of growth is peace, easy taxes, and a tolerable administration of justice. If this captures that, well, we capture something that is beyond that. Okay. Now, everybody will want to benchmark us by saying, okay, what you're saying is that what matters is how competitive countries are in making different things. So it's like the competitiveness index of the World Economic Forum. So we also benchmarked ourselves against the World Economic Forum, and we beat the hell out of them. So that means that you might want to improve in your index on the World Economic Forum, but it won't create any growth. If you improve on our index, you are more likely to grow. So at least they are capturing something about what they think causes competitiveness. We look at the outcomes of competitiveness. Okay, so we're capturing, in some sense, more predictive information than they are. So if you believe the story up to now, then the next question is, how do you accumulate more person bytes? How do you expand productive knowledge? How do you increase economic complexity? And here you have to deal with a fundamental chicken and egg problem, that you cannot make watches in a society where there are no watchmakers. And in a society where nobody's making watches, nobody wants to become a watchmaker. So this is, you cannot do things that you don't know how to make, but you do not want to learn things that are not being made. And moreover, even if you wanted to learn those things, you don't have anybody to learn them from, because nobody in the society has that knowledge. Okay? So how does the world ever deal with this problem of expanding the productive knowledge that people have? And the answer that we've found is that people move from the products they're in to products that are not too far away in some person byte dimension. So it uses more or less the knowledge you already have, plus very few additions to it, so that you can cope with this chicken and egg problem more easily. And so to capture that idea, we developed this concept of the product space, which we published in 2007 with Cesar, who's there, and some other colleagues. And this map essentially connects products in terms of how similar are the person bytes that they require. Okay? And for this publication, we recalculated the product space, that is with data until 2008. So every circle here is a product, and it's connected to products that require similar capabilities, similar person bytes, similar knowledge sets. And the colors indicate the products that are related to other products. So we have grouped them into communities, and we've applied some techniques to create these communities, these 34 communities, these groups of different colors. Actually, this green is garments. This is construction material and equipment. This is machinery. This is chemicals. This is electronics. This out here is oil. Here is tropical agriculture. Cereals are like over here. Textiles are like over here. So different products are in different parts of this space. And what we find is that countries tend to move from the products they're in to products that are related, as captured by this map. Now, different communities of products differ in their characteristics. Here on the x-axis is how many neighbors do products have. That is, if you are making a product, how easy it would be for you to redeploy your knowledge to make something else. a product that is related. And here on the x-axis is how many person bytes, how complex are these products. So typically you find here that oil or tropical agriculture are fairly simple products. They require few person bytes. And not only that, they have few neighbors. So if you learn how to make these things, you do not have what it takes to make other things, because what they require you to know are not the things that are easily redeployed in making something else. While this is here, machinery, electronics, or chemicals, they require more person bytes, but those person bytes can be easily redeployed to make many other products. So once you learn how to make, say, a microwave ovens, it's fairly easy for you to figure out how to make toasters, how to make air conditioners, or how to make other things that mobilize more or less the same kinds of person bytes in society. So let me apply this a little bit to the evolution of the world. I'm going to illustrate it with two countries, Ghana and Thailand. So Ghana, this is the years of schooling in Ghana and the years of schooling in Thailand. Ghana invested much more in schooling than Thailand. Education improved much faster in Ghana than in Thailand. And Ghana has been the star performer of West Africa. This is the growth in GDP per capita in Ghana. That's part of the story. The other part of the story is that they started to grow after a collapse in the late 70s, early 80s. But if you look at what Ghana knew how to make and infer the person bytes of Ghana by just looking at what they made, well, in 1975, they made a lot of cocoa beans, some aluminum, some wood. Essentially, 68% was tropical agriculture. If you look at Ghana in the year 2000, it's making cocoa beans, aluminum, wood, and some fish now, and some diamonds. So when you look at the evolution of what they made, of the exports that they made, you see that the colors are pretty much the same. So they're making more or less the same things. And it collapsed, it went back up. There are a couple of new things there that were not there before, or not much, but essentially that's the transformation that happened. So when you look at what happened in the product space, this is the product space. What makes this Ghana is these black squares. So these black squares is where Ghana had productive capacity. And this was for 1975. So let's look for the year 2008. You see that the black squares have expanded. So Ghana has undergone some transformation, and you see that typically the new black squares in 2008 are not too far from the previous black squares. So that they have been moving outside in this space, and they've moved a certain distance. So that's why they're the star performer of West Africa. When we look at Thailand, this was Thailand in 1975. They were making sugar, vegetables, rubber, corn, and rice, mainly some fish, some tin, some wood. That's what they were doing. It was 42% tropical agriculture and 31% cereals, so that's 75% in agriculture. This is in the year 2000. They're making 50% in machinery. They've 17% in labor-intensive manufacturers. They've completely transformed what they do. So when you look at the evolution of their exports, they're still producing the same agricultural products that they were producing before, and actually more of them, but they've added a ton of things that they did not know how to make before that they know how to make now. So when you look at them in the product space, this is where they were in 1975, where they have the black squares, and this is where they are now. So you see 75 now. They've colonized this whole product space. They have expanded to a much broader set of products. They've accumulated the capacity to do more things that they were doing before. And so when you compare the evolution of their income per capita, this is the boom in Ghana compared to growth in Thailand. So why some countries catch up and other countries are not catching up? This is, in fact, expressed in this graph here. This graph here says how many person bytes you have. This is our measure of how much productive knowledge you have. And this is a measure of how easy it is for you to move to nearby products, depending on how many neighbors do the products that you have, right? How easy it would be for you to accumulate a few more person bytes and make the next product. So what you see is that these countries have few person bytes, but they also have few neighbors. So it's hard for them to move to the next product because the next product is like too many person bytes away. They don't have too many neighboring products. These countries here have more person bytes, but they are also in a situation in which they have many products that it's very easy for them to move. And the star performer here is India, that they've now moved into a sweet spot where, given what they know how to make, it's very easy for them to keep on learning how to make other things because they have what it takes to learn a lot. And then you have rich countries where they are already sort of like everywhere in the forest, in this product space. They have very few other places to go. They have to wait until they invent new products because they cannot just move to products that have already been invented. In the middle, there are some countries that are have a sort of like the same number of person bytes as India, but are much poorly located in the product space. So Russia, Moldova, and so on. It won't be that easy for them to redeploy as it is for countries that are better located, better connected in the space that we have described. So we use this to project growth to 2020. You see, the rich countries are growing more or less at intermediate rates, but in the middle income countries, this is how rich you are, this is how fast you're going to grow from now to 2020. You have China, India, Thailand, Moldova, and the Ukraine being countries that we predict are going to be the fastest growing countries in the next decade. Okay? But there are countries that today have similar levels of income, which we don't see them as catching up. We see them as falling behind even the rich countries. So that's why we say it's not that everybody is going to catch up. Some countries will catch up. Other countries will have a more challenging situation because of the way in which this productive knowledge can evolve. So this is expressed as the map of the world. So we see a lot of growth in China, India, Thailand, Indonesia, and so on. Mexico, we are the only ones to predict that Mexico is going to grow faster than the rest of Latin America. Mexico is a more complex economy than the rest of Latin America. So Brazil is actually ranked number 4. We see growth, a lot of growth in Eastern Europe. Eastern European countries are surprisingly poor for the complexity of the things they know how to make. So we think they are poised to catch up. There's no reason why they should remain as poor as they are. And we see a lot of growth potential here in East Africa, and much less so in West Africa. This was in per capita growth. This is in total GDP growth, that is including population growth. So you see there this East Africa being a focus of growth. Pakistan is here as also a fast-growing country in terms of total GDP, less so in terms of GDP per capita, and a lot of growth in Eastern Europe. So, but the issue here is not just to predict what's going to happen, right? Because we're not just in the business of predicting. The issue is to find paths that can make the accumulation of person bytes, the accumulation of productive knowledge and its expression in more products and more complex products more easy. So we need to find paths. And that is the reason why we have these maps. So as we say, a map doesn't tell people where to go, but it will affect where they decide to go because it points out what are the options, the paths, the pitfalls. Now, when you give somebody a map, you don't need a central planner either, right? Because there are many people who are going to be exploring this space. There are many people who have to make the investments, try things out, figure what can be done. And that's why we have created these maps as a way to empower them to figure out how they can contribute to the process of economic development. Thank you very much.